The first part of the question says a chicken cutlet provides 6.9 times 10 to the power 2 calories of energy. Okay, my pen is skipping a little bit, so excuse the bad handwriting. We also know that a food calorie, remember your unit conversions here, a food calorie is equivalent to 4,180 joules. So we're going to do 4,180 joules divided by 1 food calorie. So that's going to give you the answer in joules, and I'm guessing we need the answer in joules. I don't know that yet, but we're going to do 6.9 times 10 to the power 2 times 4180, whatever this answer is, that in joules is the energy given by a single chicken cutlet, right? Now the second part, the minute you read the first two lines, this has to strike you as a unit conversion problem. Okay, and I'll tell you why again. The heat energy provided by the cutlet, which is this energy, let's call it Q. Okay, when the cutlet is burned, what's happening? It's generated, right? It's an exothermic reaction. So the cutlet is losing energy, kind of. And that is going to heat up 59.1 kilograms of water by how many degrees Celsius? So this heat is now gained by the water. So G for gained. Okay. How much heat is gained by water? Let us calculate what this value is. And that answer is, I'm just going to write that in a different color right here. So that answer is 2.9 times 10 to the power 6 joules. That's a lot of energy, okay? This is how many joules a single chicken cutlet generates. Note that I have kept just 2 sig figs as needed for the calculation. Now, how much energy does water gain? What needs to remember, this is heat gained is heat lost. The cutlet is releasing heat and the water is losing heat. So immediately we're thinking MC delta T. MC delta T of what? Obviously not the cutlet, because you already have the energy of the cutlet. We have to figure out the MC delta T of water. Okay, so M is the mass of the water. What did they say the mass of the water is? Okay, they said 59.1 kilograms. Okay, let's write that down. C is the specific heat of water, 4.18 joules per gram per degree Celsius. Okay, already we know that we need to make our units match up. So here we have joules and here we have joules. I think I should start changing my color right now. Okay, so that matches up. But here we have grams and here we have kilograms. So let me convert this to grams. So that's just going to be multiplied by 1,000. So that's 59,100 grams. Okay, and we don't know delta T. So now what's going on? So we're just going to scroll down a little bit, and here's our equation. Our equation is that the energy, and I forgot what that number was, hold on. It's 2.9 times 10 to the 6. Energy given by the cutlet, so Q cutlet is the energy gained by the water, correct? Now Q cutlet is 2.9 times 10 to the power 6 joules. This is MC delta T, which is again, I'm going to simplify 59,100 to 5.91 times 10 to the power 4 times specific heat, which is just 4.18, times delta T, which we don't know and which is what we're calculating, which is totally fine, okay? Now therefore, delta T is equal to 2.9 times 10 to the power 6 divided by 5.91 times 10 to the power 4 times 4.18. I like to do a lot of the exponentiation by hand. 10 to the power 6 by 10 to the power 4 is simply 10 to the power 2. So I'm going to do that. And then let's calculate the remaining. The answer is 11.7, and since we are calculating delta T, the units have to be degrees Celsius. What do you think happened to the water? Did it get heated up or cooled down? Obviously it got heated up because the cutlet was generating energy. Since the question simply asked for delta T, this is your answer right here. Make sense?